Alrighty, hello everyone. Now it's time to walk through a demo of a simple Java networking application using NetBeans 8.1. For this tutorial, I chose the most simple multiplayer game I could think of, because, who doesn't like games? Um, so we're going to be writing a simple memory matching game, and you can follow along line by line. We'll be learning about Java's socket and server socket libraries, along with others that we require, to create a server-client architecture that we can use to synchronize the game state between both instances of the game. The synchronization of the game state is probably the most tricky component of the tutorial, and I will do my best to explain all the nooks and crannies that we need to keep in mind. And so before I get into it, let me show you what we'll be creating. So if I run here, I need to run two instances of the project. So we got one here. Now as you can see, I've used simple 4x4 grid. We can add more. I'll talk about that when I start the coding walkthrough. Now as you can see, this instance has become the server because it's tried to connect to a server, couldn't find a server, and then it initialized a server. As you can actually see here, I've got some prints to show you. Ignore that's my stuff. So trying to connect to a server, unable to connect, so we're going to become the server. Now we're waiting for a client, as you can see, can't do anything just yet, so we're going to create a new instance. Because this is grayed out, I just go here, run file. You could also create these, run these instances from terminal, because they're runnable, or you can even create them as a jar file, whatever you please, but this is the quickest way for me to show you. So now our client, the second instance, has connected to the server, and the server now shows it's his turn. So let's go ahead and click two things. Right off the bat we got a match. Now as you can see, the matches, if it's your turn, are blue, shown in blue, and on your enemy's window, they're shown as red. The winner is the player who has the most matches, logically, and if you get a match, you have another turn. Now, you can use images for this, whatever you please. Personally, I've used simple text because it's easy for the demo. So let's keep going. Oh, we got one here. See if you can recognize the names. Sim here. Yes. Alright, who's going to win? Oh, it's so intense. Not really, sorry. Alright, so the server is the winner, as you can see up here, and Boohoo, the client, is the loser. There are three end game states, which is win, lose, or draw, and they're shown at the top here. Now, as I said before, this is a very simple application. This is not a JavaFX tutorial, okay? So obviously everything required in this tutorial I'll explain, but if you want to go ahead, make some cool flip animations, if you want to have a nice end-game message, you can do that. We're going to focus on the networking aspect of this tutorial. So let's close these up and get to writing some code. So let's create a new project here. Make this bigger. New project. Now we're going to create a JavaFX application. You might be wondering why not FXML. And my personal opinion is if you can't write a GUI in code, you shouldn't be cheating using the interface builder. That's just my 2 cents. And it's good something to learn as well for the tutorial. Now, what should we call this? Let's call it demo. Why not? And everything else is alright. So, right off the back, we get our standard start thing. Let's delete that. I don't want to confuse anyone. We're going to go one step by step. We'll leave those imports there. So, the first thing we want to do is make this runnable. So, we want to implement the runnable interface, just like that, and immediately, thanks to NetBeans, it's going to tell us to implement all the abstract methods, and that is run. Currently there's nothing in it, and we'll go through that in a second. Now, where should we start? Let's reorder these a bit, because I like keeping this clear. So what we're going to have here is our main first of all. Now this is the main, obviously this gets called first, launch args, then calls our fxml application to be run using the JavaFX thread, and we start building our interface. Now we're not going to start with that just yet. First, let's create an instance of our class here. And let's create our public constructor. Now, first things first, let's talk about which fields we're going to need. Now, there's a lot of them, so you're going to have to bear with me here. I will try doing it as quickly as possible. Let's section them off. Let's first have our networking fields. Then we're going to have our game logic fields, and we're going to have our GUI fields. Now, let's get into this. So, networking fields. We're going to need an IP. So, I'm going to make it private. We all know why we need private, because we don't want anything outside this package to be using it. Not package, sorry, class. And we're going to go final string IP, because this isn't going to change. And we're going to use localhost. If you want to do this over multiple machines, then you can put in a proper IP. So then we're going to need a port. Our port can be anything above, what is it, 1000 something or 2000 something. Let's be safe and just make it 5 twos, and that's not a string. We're gonna also need a thread. Now we can get into this more later, but one thing just quickly while I have you is that JavaFX is not thread safe. So what I mean by that is the GUI that's updated using the fxml loader in the application is in one thread, and because we're using a simple application here, we're not going to have any other classes, we're not going to worry too much about a complicated MVC model, although this is a very good application of it, just don't want to focus on that. We need to create a different thread so that we can update the GUI. Look, let me get through that. I'll explain in a sec. Now, we need some sockets. So, we need a private socket. We need a private, we'll fix the imports in a second. We need a server socket. Server sockets waits on connections on a particular socket, and a server socket does the rest. I said socket a lot. Let's import those. Yes, they're not used yet. They will be. Oh, let's do that. Now, we are going to create what's called input and output streams. Specifically, two different types. We're going to need a data output stream, which I will call, let's call it output turn. There are two things that we're going to have to be passing from one instance to the other, and that's the turn you make as well as the board, because we can only have one instance of the board, which is what the server will create. So the data output stream, which can transfer bytes, or in our case integers, recorded as bytes, and the board, because it's an array of strings, we need to create an object output stream. So, and to make that clear, I'll make that output board. Okay. So, moving on, we will also need to have a private boolean is server, so we know if this instance is the server or if it is the client. And we need to know if the client has been connected. So we'll say client connected. Now, we could initialize these in our constructor, but it's easy if I write these now, so I keep it all in the same chunk. Now, One thing, I don't handle errors ideally, but just for a basic thing, we're going to create a boolean to see if we've lost connection, and we're going to have a simple count for number of errors, which essentially, when the number of errors, say, reaches 10, we're going to recognize that a connection is lost and we'll quit again. Obviously, you would want to implement something more advanced, I guess, if you want to like try reconnecting if connection is lost, but we'll leave that for another tutorial. Now, what about the game logic attributes? Well, we need to keep track of whose turn it is, so private boolean my turn, and we're going to set that as false. When you'll see later when we reestablish that. Now we'll have, this is now going to be our list of words. So a string away, we'll call it word list. So that's just the words. That's not like the matches that we need to have. That's going to be in our board. So that's going to be a board string array board. Now, obviously, the length of this board will be twice the length of the word list. And you'll notice here that it's not final. That's because, as I mentioned before, the server will generate the board and then send that to the client. We don't want the client having its own board, because then we're not going to have it. And obviously, the board's generated randomly every time. Now, we want to also know the number of columns. This will not change. And the number of rows. This will be used for our GUI. So why is it here? Good question. Went a bit ahead of myself. Now, number of rows. Great. Now, am I missing anything? Yes, I am. We need to keep in mind what's been selected. So we're going to need a toggle button. Now, I've decided to use toggle buttons as my control node for each tile. Because I'm not using images, it's quite easy. I have the button with a certain text, and then I can simply hide it or reveal it using simple CSS. And it also does the nice toggling the state for the selected state on and off. So it was a good idea for me. Now, selected one, this is going to store, yes, let's import that please. This is going to store the first selection, whether it's you or your opponent, and naturally selected two will do the second. Now, if these are null, or one of them is null, we haven't finished a complete turn, so once they're both not null, then we can check for a match. Now, let's also keep track of how many matches I made. So my matches and op matches, opponent matches. We also need to keep track of the game end state, so that will be, let's just call it game over and set that to false. Now, this is the first little tricky part that we need to talk about in terms of synchronizing this state. Now, the game state update flag will be used to make sure that when you click on a tile, we need to register that we need to do something. Now, we don't want to always run a particular method immediately when we click it, because that's running the same thread. So for example, if you click on two tiles and they're incorrect, we don't want them to flip it around instantly. We want to wait maybe 1 or 2 seconds and then flip them. But if we call thread.sleep, which is what we use to pause our application, it's going to pause everything, and we don't want that. So to simplify it, instead of worrying about concurrency in the JavaFX library where we can use a task class, for example, and so forth, you can look into that yourselves, we're going to raise a flag, and then on our game tick, which runs infinitely until the game is over, we're going to notice, oh, something happened, and let's process that. So when the game state is true, we're going to need to record what was pressed last. So let's just call that, I don't know, last tile selected. Now, you notice I used the word tile here. That's because we are going to be using a tile pane for this. So what is a tile pane? A tile pane essentially is a nice way of distributing n number of node objects in a particular area, and it equally sizes them and makes it nice. So we want a tile pane. I'll get into that in a sec. Now we're going to want to have an instance, not an instance, but point it to the stage so that we can set the title of it, as you saw. And finally, let's just choose a size for all our tiles. So private final, what should we call it? Well, it's a double. Because it might be divided depending, and let's call it tile size. Give it 100. All right. I believe that's all we need right now. If I'm forgetting something, I'll remember later. Now, let's go into our constructor. So the first thing we need to do is get our word list. Okay. Now this is important. Remember that the word list needs an even number. Actually, that's completely wrong. Disregard that. I just started thinking ahead of myself. Now, let's create our word list. So we want a new string array, and because I don't like having multiple lines, let's initialize that immediately. What word should we use? Animal, something. Let's just follow the example I showed before. So Sim shout out, Leo shout out, can't forget Michael. Now me, surprise, I forgot, I don't even know how many I'm on now. Let's just go Alex, Max, and I think, what did we have? We had 8 last time, right? 1, 2, 3, 4, 5, 6, 7. Last one. Let's go with Paul. Good as name as any. Now, this is my little way of having it. So we want to have the board in a square. Now, in case the user has not created a board a word list whose, if you multiply it by 2, is not a square number, let's do the following. The number of columns will equal. Now, first, let's find out how many we're going to have. So we want the word list dot length. We're going to multiply that by 2. Now, we want to square this. So ideally, if that was a real number, that would be how many columns we have. But what happens if it's not, if there's more or less? Let's round up to the closest square number. So we have that, and yes, typecast it to an int, and yes, close that off. No more complaining, good. And because it's a square, then we can say the number of rows is the same as the number of columns. So now we have that. Now, because this is the constructor, as I said, and you saw in the demo, when you create an instance, we need to first check, is there a server we can connect to? And whenever you're doing anything with sockets, you want to use, well, I got ahead of myself again. So, check if there is a server we can connect to, otherwise become the server ourselves. So, if, now, let's make that into its own method. So connect to server. If that returns false, then we are the server. and else, we'll worry about else later. So, if we connect to the server, then if we don't connect to the server, we're going to need to initialize the server. And then after that, we're going to need to create the board state. So create the initial board state. So that's 1. And then 2 will be wait for client to join us and send them the board, the starting board state. Now, we should first... Okay, these two methods here we're going to talk about in a second, but while we're in this constructor, let's construct the board state. So for this, I've decided to use hash maps because I don't like dealing with one array for the strings and one array for the counts. Keep in mind we can't use an int here because we need an object, not a primitive type, and this will store the count for the words. So every word will need a count of 2 by the end, and this will keep us something. So let's create that. Do you need to import? Thank you. Now we have to go through every string in our word list and add it to our word count. So word count dot put. Yes, I do want s, and we want to give a count of 0 to begin with. All right. So all we've done here, we've created a hash map. For those who don't know, instead of an index into an array, which has one object, this is a collection of strings and an integer related to each of those strings. Now, we need to create the board. So we need to, let's first initialize our board array to a new string array of size 2 times the word list's length, because we're playing a matching game, so every word has a match. And now let's iterate through the board length. Now we're going to need to create something. So let's first get a word. So let's make this the word, and then we need to choose a random word in the word list. All right. So how are we going to do that? We're going to index, and with this we're going to use a random number. So let's do a space so you can see. We need to math.random. This will create a random number, and then to make it between 0 and the end of the array, let's do word list dot length, and this is a double label, no, long, doesn't matter, let's make it mid. So there you go. I personally hate these spaces. So now we have our word, but we need to check if we already have 2 of these words on the board. So we'll have a while loop. While, now we check the count. So we go into our word count hash map, and we can index by the word, which is nice. And we need to check if that is equal to 2 or greater, just to be safe, but it should never be greater. Then we make a new word, find a new word. So a very simple way of doing that. And then once we have it, we're going to increment the count for that word. So that's a simple update. So we need to actually, for this word, we get the count, which was this, and increment it by 1. Okay, I hope that makes sense. You can't just do word count dot get word plus plus. That doesn't work. So we've incremented that, and now let's add this word to our board. So board I equals word. Now, I should explain. We haven't used, we've used a string array because we need it to be ordered. We don't want it to have a list, even though you can have lists, but yeah, let's not get confused. So we've created that. Now, this, we don't want to send it immediately to the client. We don't even know if they've connected yet. That's going to be later when we have, we'll get to that. Now at the end, let's create just a new thread. So thread, get this and give it, I don't know, demo's fine. And let's start that. Okay, so we still have this and this to do. This looks fine. What are you complaining about? Okay, just wanted a better cast on this one, same thing. Nice. This is a silly error. It wants a diamond interface, but I want to specify what we're using. There's no difference, but I'm used to it like this. So here we need to fetch. So this is if we're not the server. So because we are not the server, we need to fetch the initial board state from the server. So let's make a method there. Let's call it fetch board state from server. So now we have three methods we have to implement. Now, all of these have stuff to do with our networking. So, because I like to keep this neat, and also for you guys following along, bear with me. Let me just segment this off. We all have our own ways. Mine is using a bunch of stars. Now, this logic, what am I saying? This is going to be the networking methods. Okay? And the first thing is connect to server. And as you see, we're using an if statement. We need it to return something. So let's say private boolean connect to server, no parameters. All right, now, because we just want to keep this like simple when we're testing it, we say trying to connect to server, and now we use a try catch. Specifically an IO exception. We want to catch an IO exception because of the following line, which is we want to initialize this socket, well, we're declaring it really, with the IP that we hard-coded as well as the port. Now, this will throw, well, no, that won't, but this will. When we create our input and output streams, that's not right, output turn, yes, I want that, data output stream. Now, for the data output stream, we need to go socket dot get output stream. Nice. Now we need to do the same for input. Now, this will cause an IO exception if we can't get that. If we can't get, oh, sorry, I was pointing with my finger. Socket.getOutput stream. So let's catch that. We say IO exception. Give it some variable e, and let's just, well, let's first tell ourselves we couldn't connect. So unable to connect to server. Let's give it the address. I don't know, you might be testing things. So the address is the IP and the port. So, yes, we need that import. do it. Yep. Now, these are methods. I don't know why I missed that. That's why we have an editor. We also want to create our output board stream, which is an object output stream, and that's the same now as this. Input board hey, it knows it's an output stream. Socket input. Okay, so we've created our streams. This is all connecting to the server, and now we need to raise our flags that the client has connected. And we also need to say for this instance that we are not the server. Cool, and let's give us one more thing. Successfully connected to server. Alright, that's our connect to server done. Now we need to return false in this case and true otherwise. I just pressed save, I hope that's not. Alright, we're good. So the next thing, so now this is not an issue, now let's init the server. So this again won't return anything, we just simply need to init it. So how do we do that? Let's first start off with our trusty print, initializing server. This is a good practice, we should all be used to that by now. Now another try catch, we're working with sockets. In this case, we're going to create the server socket, and this is now server socket. We need to pass in the port. Now this 8 is a from memory. Let's read the Java docs super quick. It's the number of failed attempts or something like that. The maximum length, sorry, of the queue of incoming connections. That's almost irrelevant for us, we just need one at a time. So we just set it as 8, it's pretty standard. And now this is where we need the inet address get by name IP. We're going to need to import that. And what that's doing, if we go back to that, I shouldn't have closed it. That is the local inet address the server will bind to. So that's an input parameter for this. So nicely like that. So try, and what are we catching? We're going to be having to catch any old exception in this case. And the standard thing when you do that, let's just print the stack trace. These won't actually never happen. Well, they will, but we're not going to handle them. And obviously now that we've created the server, we should really be doing it here. Let's say my turn is true because we want the server to start first, and we want this server to be true because, well, we're the server. So now that's those two done. Now this fetch board state, I'm going to cover that when we talk about sending the board state. So let's now, the reason I want to cover that later is because, as you can see here, even though we've created the board state, we're not going to send it to the client yet because we don't know if they've connected. So this will actually happen in another method that we're going to call, I don't know, listen for server request or something, and then we're going to worry about that. So bear with me there. Now let's move on to our run method. So the run method is called when, well, because we implement the runnable interface. And here what we want to do is, bear with me a sec, this is where we're going to have our ticks and so forth. So, because we're not having any reset buttons or something, we can keep this nice and simple and say while not game over, do stuff. Now, this is where we're going to introduce a method called gameTick. Now, for those who have never made a game in their lives, you need to know one thing. A game works very simply. You have a infinite loop until the game is over. And every time that loop runs, it's a game tick. That's what it's usually called. And on that tick, we need to process everything. So if we're using, that's when like it notices a state change to the board. We need to run it on both the server and the client, make sure everything's synced, and then maybe, I don't know, conclude there was a match, there wasn't a match, and so forth. Now, this is going to run continuously. We're going to get to that in a sec. But because this is the first method that runs, we want to check if the client is connected first. So if we're the server and we haven't had the client connect yet, this is where we want to listen for a server request. Now, remember how the server is running on a server socket? We can actually stall until we have a request. So now let's write this, listen to server request. So back up here in our networking methods, let's create one more method called listen for server request. So private void listen for server request. Now we're going to create a socket, which will be null for now. And we're going to try, we're going to have our server socket, which we initialized in our construct, not in our constructor, but in our if connect initialize server. No, that's not what we want. What do we want? That's right. We want to get our socket and call our server socket accept function. Now, what's important to note about this accept method is that this line will block the program until it receives a request. It's very handy for us because we don't want to do anything until we receive the request. Have I made any mistakes here? Why are you complaining? Of course, because we need to we have to catch the error. In this case, the error will be an IO exception, so let's go ahead and catch that. X. And let's print this stack trace for that too. Now, this is now when the client joins the server. So we need to make our input and output streams again. So I think we can copy this. Now, I can hear you shouting through your screens already. Code duplication, yes. This could have been put in a separate method, but I want to keep the logic in the methods. I'd rather you understand what's happening in each one rather than jumping around into all these compartmentalized methods. So we're waiting on a request. When we get a request, we create our input and output streams, and then we have to update that the client is connected. The client is connected, however, we are the server, and it's our turn. Looking back on this now, I believe this is a bit of duplication. It's more just so we know what's happening. I'd rather be safe than sorry. So, moving on. This is now where we want to send the board state to the client. So, now that our client has connected, let's send them the starting board. So, this is our first input into our input stream, or output stream in this case. Now, let's first write send client board state, so we can work on the fetch board state and send client board state together in our networking methods. And after that, just before we start, we want to make sure that all the tiles on the board now are enabled, so not disabled, so that the server can have their turn. Because like we said before, they're all disabled to begin with. So let's say allow server to start turn, and let's create just a method for this. We'll call it disable tiles, and the parameter, let's call it, let's just make for readability, not disabled, or let's call it disabled equals. What? I'm so confused. Look, let's just do this. You'll see I'm thinking in advance. So disable, let's make that false. So this method here, disable tiles, is going to take in this parameter. If it's true, we're going to disable all the tiles, and if it's false, we're going to enable all the tiles. We'll get to that later. That's easy stuff. So now let's work on, we've finished this, and now we have to address this and that. So because we're in the networking here, let's do our fetch and send board states. So let's do send first, why not? Private void send, no suggestions. Do you have a suggestion? No. Okay. Client board state. This is very easy. All we have to do, again, encapsulating in a try catch, we're going to say that the output board, we're going to write to it, and we're going to write an object. This is why we have two different streams. The board is an object. It's not. It can't be a byte. If it was because it's a string array, we can serialize it into a string of bytes. But this is a nice, easy, intuitive way to do it. So we just send an object, send them the board. And we also want to flush the output stream after that, so we don't send anything twice by accident. Flush. And we need to catch, this is an IO exception. Let's do that. Let's do e.stacktrace. And also here we want to increment our number of errors. So num errors plus plus. Now we want to do the fetch board state from server, I believe it was. That needs an L. That's why I didn't have any suggestion. Fetch board state from server. We need to initialize our board as a new string array. 2 times the word word length. Then we try. So we're going to be passed in a string array. Let's call this from server, because the type isn't saved. This here will pass out an object. So we're going to do from server equals, we want to typecast this as a string array. And we're going to say input board, so this is the stream, and we're going to say read object. Fairly intuitive. And now we want to clone that into our local field board. So let's just say board equals from server dot clone. For those paying attention, we can't just say board equals this, because we're just going to have a reference to it. We want to clone our own version of it, and then this can be cleaned up. And let's catch it so it stops. Look, this one has a few issues, so let's throw all the... No, that's not what we want. In this case, there can be an IO exception. Ooh, it's fun working with exceptions when you're doing this. Yes. And it has one more problem because we haven't implemented another exception, class not found exception. So let's catch that as well. There it is. Another E, why not? E, print stack trace, please. Thank you. Now, why do we have an issue here? Print board state. Fetch board state, sorry, is that the same as fetch board state? Yes. Let me just have a look at this for a second. Ah, that's why we don't have a return. Void. That's what happens when you type in quickly. Now that we have, this is all the networking things we need. There's one little thing here, we'll get to that later. These are all our networking methods. Now, before we get into the game logic, let's write ourselves a GUI. So I think it's a good place to do that right after this. So let's copy our little separator. This is going to be our application GUI methods. So we all know that the first method that's called is the start method. So where are we? You, come here, we need you. Your Call of Duty is now. Alright, so we all know how to do this, don't we? We need to get this, save a reference to the stage. Done. Oh. I don't want you to throw any exceptions. And let's keep this what we're used to in our lectures. So, primary stage. I think that's easier. So we've got our primary stage. Now, we want to create our tile pane. So new tile pane. And we want to set two parameters first. Let's first set the number of cols and the set ref columns, num cols, and tile pane dot set ref. Can you figure it out? Oh god. Good. Num rows. So we have that. Now, we need to create two buttons for every word in the list. Right? Or in other words, for every tile, we need for every word in the board string, like string array, we need to create a button for that. So, for int I0, is there a, no. I've forgotten my shortcuts. You guys must be really annoyed at me right now. So, board.length. So for everything here, we want to create a button. So how do you add something to a tile pane? Well, like any other container, you get the children array, then you, list, not array, and then you add, and now let's make this nice in a separate method here, create button. It's a toggle button, let's just call it create button, and let's give it a parameter I. This I will be the index, and we'll get to that in a second. Okay, so let's go straight to that actually before we continue, because this is something we need to know. So private, now this is returning the object we're trying to add to the tile pane, which is a toggle button. So toggle button, create button, and give it some index. Okay, now let's go quickly. Let's call this button, new toggle button. Now, this is where we want to give it a string, the name. And we know that when you create a button, if you put in a string like test, it's going to be test. Now, this I, we want it to be the string which is related to that board element. So we're going to say board index. And that's going to, this will give us the word from that board, and this is going to create the button with that word. Hope we're all following. Now, let's set its height. So set pref height. That's why we have a double. We call it task size. Good job, NetBeans. Can you do it again? Okay, I was getting a bit difficult there. There you go. All right. Now we need to. Now this is an interesting part. What happens when we press the button? Okay. Now because it's a toggle button, it has its own way of handling the selected state and unselected state, which is fine. We have no problem with that. So the same way in Scene Builder, if you were to click on the code thing on the right and select the OnAction button, here we can just assign it manually. So dot set OnAction. We need to make a new event handler. Can you, yes please, new event handler of type action event. You've got all these different mouse events and so forth. We want action event. Just trying to remember. Yep, and let's create a method inside that. There we go. Now we need to, let's see if it wants to help us. Yes, okay, that's a help, but does it want to? No, it doesn't. Okay, I have to do it myself. Let's go at override. Public void handle. Now what? We have to pass in the event. Give it some value E. Now, let's first get what button was pressed. So toggle button, let's call it the source, is equal to E dot, that's the event, and the event we can say get source, right? Now, this is not, this could be anything. An event can be called on a bunch of different pardon me, control types. So we want to typecast that as a toggle button because we know it's always going to be a toggle button. Next, we want to set the last selected tile. Ooh, what is that? The last selected. Now, can you help? What did we call that? Last tile selected. That's why I'm having an issue. The last tile selected to equal the source. So we keep in mind what we've done. And then we need to flag that the game state update is true. Now, I don't like game state up. I want it to be updated. So let's refactor that. D, go ahead. Boom, nice. Now, button, what is this one? Yes, we need that import, thank you. Ah, beautiful, all done. So, let's go over this. We are manually overriding the handle event when this button is pressed. And on the specific action, we are getting the source. So on which button was this event triggered? We're typecasting a toggle button and saving that, saving a reference to that, and putting that as the last tile selected. We're also raising a flag of the game state has been updated, and in our game tick, we're going to address this flag and process what happens. Note here, we don't need to change any styling and so forth right now, because it does that for us, but because it's quite ugly, the default one, let's quickly sidetrack here and create a cascading style sheet, call it, I don't know, style. Where we want it here, cool, and let's quickly add what we want. So let's use the default things. We don't want to have to be adding classes to things. So default, this toggle button, let's set the focus color, so that's a little blue thing around it. We want that to be transparent. We don't like it. Next, we want to have the text fill color to also be transparent, because we want it to be invisible until we select it. And let's just give it a bit of a larger font size, 18 pixels. Alright, done. Now let's do the selected state. So we can simply do this, selected. Now when it's transparent, sorry, the text should now be black. The focus color should always, it's always going to inherit from the previous classes, so that's fine. But we want the background color to be invisible now, because we don't want that ugly black one, and this will be inherited as well. So let's go FX background color transparent. You can make this whatever you want if you're feeling fancy. And we also want to have one for disabled. So disabled is how we prevent the user from clicking something again. Because in this, you don't want to have them cheat. Flip it up, and then it will flip it down. So the disabled, by default, will set the opacity to half. And that looks ugly. We don't want that, because it sets the text and everything. So we just want to override that by saying that the opacity will always be 1, even when disabled. Cool. Now, we're going to go to this later, but if we find a match, we're going to add this class on top of the toggle button, and this is just going to set the background to transparent and change the text to, now if it's an opponent match, we want, what did we say, red. Yep. And if it's my match, let's make it blue. Alright, now let's get back on this. Let's close all this. Alright, so now that we're here, create button. What are we doing with that? Why you? Well, that's right, we need to return the button. So, back to this, we need to create a button for each thing. That's fine, that's easy. But now, we want to disable all the buttons immediately. Okay, so remember how we haven't created yet, but disable tiles will say true. We want them disabled. Okay, disable tiles. And now let's create our root. So it's a stack pane, like how much of a pain it is to type all this out. Huh, jokes. Stack pane. And now we're going to add our tile pane to our root. So root.getChildren. I can do this with my eyes closed soon. Add tile pane. Now, do you not have our imports? Are you happy now? Cool. And now let's get our scene. Now, how big do we want our scene? Well, we want our scene to be from the root, and we want it to be the number of columns multiplied by the tile size by the number of rows multiplied by the tile size. Thank you. And we also want to apply our style sheets. Oh, look, we had just finished those. That's good. So, style sheets, get style. Let's import that so we can use our autocomplete. Thank you. Style sheets. Now we're going to add. Now this is we have to get the class of the resource. What do we call it? Styles, right? I think so. No, style. Style.css. And the important thing, to be quite honest, I don't know why NetBeans wants to do this, but external form. What have I missed? That's a comma. That's wrong already. Easy. Now, we want to establish the text on the top of the scene. Yeah, so how about we say if we are the server, let's do that, not negative. If we are the server, then let's make a new method called add string to title. And let's say we're waiting for client to connect. I think that's what I wrote. Else, we want to say add string to title connected to server. So this is what happens by default. After the game tick happens, it's going to change to my turn, opponent's turn, so forth. And what we want to do here, instead of having it as just what is it, like scene dot like set title, whatever, we want to always make sure that it says server or client, just to keep that consistent. So that's why we're doing that here. So why don't we quickly go, well, we don't need to write this now, do we? Oh, fine, we'll write it now. Let's do that. So private void, what did I call it? Add string to. I hope my typing's not too loud. I really apologize if that's the case. I don't want this to be too long for you guys though, that's the only problem. So let's get let's call it a client server string, and it's going to be, by default, let's be the server. So if we are not the server, what do we want? What do we want? We want, well, we want client server to be server. And now we're going to add this, so you'll see in a second, client. Great, and now here we just simply say, now this is important. I was having some funny things here in terms of what gets first, the run method or the start method. The run method actually gets first, so to keep it simple, let's just not try to access the stage if it's null. So that's an easy fix for that. So if it's not null, then we say this dot stage dot set title is client server string plus s. Well, no, let's give it a little. I think that's what we did. Let's do this. S. Okay, and that's just going to print whatever we have here. We use it later for my turns and things like that. Let me just check one thing. Did we call that stage? Yes, no stage. Cool. I kept saying scene for a while. I'm speaking too quickly. So now, where do we go? Where do we go? So this is what happens. We've created our GUI. This disabled tiles we'll get to in a sec. I know it's the only error we keep seeing. But now we have the game tick. And this is what we need to do. So the game tick. Let's get that up now. And this is our game logic. So where is our run method? Where'd you go? Probably faster to do that. There you are. No. So now we are doing the game logic. So let's get another separator. So, as I told you before, the game tick runs all the time, and now we need to write the game tick. So, it returns nothing. And this is now the how we handle everything in this game. So, the first thing we want to do is check we still have a connection. So we have that global num errors, so we just want to say that if num errors gets greater than 10, we're going to say lost connection. And why don't we use our new add string method and say lost connection. Now, here you can handle a lot more things. Try reconnecting. We're not going to worry about that now. Let's leave this here in case you want the code. So this will be try to reconnect, maybe, if you have time to implement that. Now, here's where we want to quickly update whose turn it is. So we in that string. So we want to say we want to ensure that the, let's call it, turn labels are updated. So if it's my turn. Why did you not want to close that off for me? Thank you. If it's my turn, then add string. What do we want to say? I don't know. My turn. Easy. Else add string opponent's turn. Now you can see now why we wanted to have that in a separate method. This add string, because otherwise it'd be messy, always getting if it's the client or not, and so forth. Now, this might look too simple, but we're going to have to move this somewhere else to keep it neat. We want to check if we or the opponent have selected selected anything, and we want to, what do we want to, and we want to update the board state. So let's call this update board state on tile selection. That's a very good name. So cracking on, let's keep going. Private void. Oh, thank God for copy and paste. So what are we doing here? First, what tile was selected? Toggle button selected tile equals null. The reason I say null is because if it's our turn, we have last selected tile. That's fine. If it's not our turn, we need to read it from our input stream. So let's first let's address that separately. So A, my turn. If my turn, do stuff, and make it nice and separated. B, opponent's turn. If not my turn, do stuff. Okay, so what do we want to do if it's our turn? If it's our turn, it's not only if it's our turn, but also if the game state has been updated. Because if it hasn't been updated, we don't want to keep running this checking for matches or what have you. So that's only for this flag. This is why we set the flag on our onAction event here. Cool? So if we've pressed on something, we want to instantly retoggle this. We don't want it to be on again. We're currently processing it, so we can set it off. Now, the selected tile is simple. The selected tile is equal to the last tile selected. Easy. And from there, we want to disable all tiles. Don't let the user select more tiles after tiles. Yeah, while we're processing it. Actually, no, what am I saying? This is, we don't want the user to press the tile again, right? So don't allow user to toggle off the tile they just selected. And by doing that, we just say selected tile dot set disabled is true. Easy. All right, now we need to send the action we made to the opponent so they can update their board state. So you guessed it, try catch. So we want to go to our output turn this time, not board, because it's simple data and it's super easy. We just say write, what are we writing? An int. Because I said int. Because this is simply the index of this tile in our tile pane. And then the user will set it. That's because the client has the exact same board state. So all we need to do there is, well, we need to find out which index that is. So let's write a separate method, get index of tile, and we'll pass in the selected tile. That's right, selected tile, and let's just write that instantly. Private, not void, int. Get index of tile. That's a toggle button. Call it B. And we have to just, okay, this is super fun. Int index, start at 0. I'm sure all of you know how to do this. The thing here, though, is that we need to iterate through the children elements of our tile pane, and if it's equal to the toggle button that we're looking for, return that index. The problem is when you type in tile pane dot get children, as you can see here, it returns an observable list of nodes. Now, a node doesn't know it's a toggle button, and we need to check if they're the same. So tile pane dot get, what am I saying? Node in that. Yep, that's what we're doing. You don't know what nodes are? I thought like everyone knows what node is. There we go. for this, that, if n dot equals b, or tile, button. If that's the case, return index. If it's not the case, well, crash our entire program. Again, I'm showing you networking, I'm not showing you safe code. Well, that's a bit of an oxymoron, but we'll get past it. So, back to this, we're going to output, now, this is not, we haven't caught the exception yet. So first, we have to output our, we have to flush our output. Good. And let's catch our exception, so that our red ugly lines don't keep bothering us. So exception E, you guessed it, we're going to print the stack trace. And this time we are going to num errors ++. Alright? So we're going to, this is sending the user, the other user, which one we selected. Now, what if there's more things to do, but we'll get to that here because they have to be done no matter whose turn it is. Now, if it's the opponent's turn, we need to get what they did. So in order to get it, it's almost like this, but separate. We're using our input instead of output. So we're going to have another try. And we need to get which index it is. So let's just have some tile index. Let me turn on my keyboard light. I can't see anything. 2 seconds. Alright, tile index. And here we say input turn dot read. Can you guess what it is? Int, because we just wrote one. Easy. There's our tile index. Now let's get the actual tile at that index. So selected, what did we call it? Tile equals. Now we have to typecast it as a toggle button. Toggle button, get our children. No, children. Yes, thank you. And get at index, tile index. Alright, now let me explain to you why we need this toggle. So, selected tile, if we didn't have this, okay, we get an error. The error is cast a toggle. Okay, well, we already know. It's a toggle button up there. But the reason we need to have it as a specific toggle button is because we need to simulate the opponent's tile press. And nicely, this can be nicely done by saying selected tile dot set. Ooh, there we go. Selected as true, and that's going to like literally toggle the button for us as if the user pressed it. Now let's catch the exception. We're doing this. Ha. That was quick. Now, what do we do? So this has made the boards updated, right? Whether it was the opponent's turn or our turn. Now what do we have to do? Well, first we need to assign. Remember we have our two variables here. Selected 1, selected 2 here. We need to assign that to that. So let's just give you some comments so I can give you this code and you can still understand it. So assign selected tile to compare if match. That's good enough. If selected 1 is null, then i.e. we haven't had a match yet, then we say selected 1 equals selected tile. And then else, i.e. selected 1 has been selected, this is the second one. So we're going to assign it to the selected 2. Nice and simple. And now, if 2 tiles have been selected, we need to check for a match. So if selected 1 does not equal null, and selected 2 does not equal null, we need to check for match. Easy. Now, let's write that. Check for match. Down here. Keep in mind, this is all the game logic, so we're keeping it up here. If you want to take this one step further, make a nice MVC, then all this game logic stuff can be in your model, and it's controlling the model of the board, and then your controller can be, well, the controller can do update board state, and then this individual thing be part of the model. So what am I doing? Private void check for match. Now, when we're checking for matches, we don't want the user to be selecting anything else. So straight off the bat, let's just disable all the tiles. Disable tiles true. We still haven't written that. Should we go ahead and write that now before I go on? Look, I'm going to do it. Private, because I don't like that there. Disable tiles Boolean disable or not. Do that or not. I think that makes it more clear. Disable or not, and then we say for every node, or we'll call it child, in tile panes children, we want to say that if child is an instance of toggle button, I'll explain why I'm doing this in a second. If it's an instance of the toggle button, then let's get the toggle button. Toggle button tile equals typecast it, toggle button child. And then now we don't want to disable everything. We only want to disable or undisable or enable things that have not been selected yet. Because if something's shown, like a match has already been there, if it's red or blue, we don't want to make that enabled again. So we'll just simply say if tile dot is selected. So if it's already selected, if it's not already selected, then we're going to set disabled as disabled or not. Okay, easy. Now, if we didn't typecast this, we don't know that child is of type toggle button. So if we tried saying is selected, see, it doesn't have selected. So that's why we have to do check if it's an instance of toggle, then we can typecast it. We can't even typecast it without this if statement, because if you say, if you try doing this here, it's going to give you a, well, it's safer to do it that way, let's say that. So, where are we? Checking for matches. How do we check for matches? Checking for matches is easy. Believe it or not, very easy. We're almost done. If something's a match, we need to check if the string of both buttons is the same. To do that, we say selected one dot get text dot equals, because we're comparing strings, we can't use equals equals, we all know that. Get text like that. If this returns true, we have a match. So, now the question is, let's see how we can do this. If we have a match, then we want to enable the tiles again. Okay, so, oh geez. If it's our turn, enable the tiles for our second turn. So if my turn, we don't want to pass off to the next player just yet. So if it's my turn, we have to disable tiles as false. Okay? And we want to highlight, this is another method we haven't done yet, but we want to highlight my match. So actually, let's just call it highlight match. All right. So what highlight match is going to do, if my turn is true, then it's going to set the match to blue. If it's false, it's going to set it to, well, red. So highlight match, let's go back to our GUI methods here. So private void highlight match boolean if it's my match. So if my match, actually before this we need to remove the current stylings. Now this is so we don't have any weird overlaps. Why do I keep doing that? All right. Let me remind myself what I was doing here. All right, so we want to say selected one dot get style class, and we want to just clear it. Okay, and the same thing for style2. And now here, for my match, we want to say selected one dot get style. Now we want to add a style called my match that we wrote in our CSS. Remember? Cool. Remember the dot's not there. The dot indicates on the style sheet that it's a style, not an ID, and we just call it by name there. And the selected two needs to have the same. There. The alternate here is op match. All right. So that's literally all you have to do. But while we're also here, let's update our matches. So my matches plus plus and op matches plus plus. This is a good place to do that because we know we're always highlighting, and when we highlight, then we confirm that there's been a match. So where were we? Here, check for match. So we've highlighted the match. And now we need to check if game is over. So check game over. We'll have to do that here. Let's just go void check game over. We'll do that in a second. So that's if there is a match. Okay. If there's no match, let's do this. What are we doing? Well, if there's no match, we want the thread to sleep. We don't want to flip over the thing. Because it's a toggle button, the second you do unselect the tiles, then they're going to be done, and the users can't see which tiles were stayed on, basically, so they can remember. At the end of the day, it's a memory game. So to do this, you can simply go thread.sleep and give it, I don't know, 1 second. But it wants to give you some try catch, so let's just do that. You can have whatever you want here. We can, just to keep it by our standards, let's just do print stack trace. Then we have that little warning, but whatever. So we pause, and then once we pause, we want to hide the tiles. Hide tiles. And to do that, we do selected one dot set selected. So the same way as we said before, where we can toggle it programmatically, now we're doing the reverse. We're programmatically setting it to hide. So we're hiding the tiles, and now we want to swap players, because once you make a not match, you swap players, so swap players. So my turn will not equal my turn, or if you're a bit confused by that, we just toggle it like that. And then we also want to disable all the tiles to be the opposite of if it's my turn or not. So what that means is, if we've swapped to the opponent, then my turn will be false, but we wanted, if it's not my turn, we want all the things to be disabled, so it's true. I'm sure you can write out a truth table for that if it's confusing. But long story short, if it's not your turn, you can't press on anything. All right, and then let's also update our stage strings. So if it's my turn, add string to title my turn. Turn. Great. And now at the very end, do not forget to do this. We need to reset the selected tags for the next turn. So as you know, we're checking everything as null or not if it's not selected. What did I just do? So we need to set them back to null once turn is ended. Cool. Close that off. Now what have we forgot? Well, we have to check if the game is over or not. So check, do we have a missing brace here? I believe we do. Yeah, we don't need that. Okay, I'll find where that missing brace is. I've been typing quite fast, so I'm sure that's, I wrote that somewhere. Anyway, so how do we check the game is over? Well, easy. We've been keeping track of the number of matches. So we simply say that if my matches plus op matches is not equal to the number of words, word list dot length, then game over is false. Now, if it is over, then game over equals true. And now we need to determine who's the winner. Very simply, we say if my matches is greater than op matches, then add string winner. Else if my matches equals op matches, add string draw lane. Else add string loser. Loser. Cool. Now, how are we looking? Hello everyone. Okay, so I'm back. I had a bit of a break. We actually had two things wrong besides the missing brace I had here. Nothing wrong. I honestly just forgot, and they're extremely simple fixes. For example, get index of title. We forgot to increment index in this for loop because it's not using an iterative I loop like int I equals blah. We forgot to add this, so that's one. And the only other thing is, this is a very simple first year mistake. We forgot to set the scene. So here in our start menu, what is it? This dot stage dot set scene, and it's this dot, is it show? Is that what we're missing? Let's give it a go. So, if you're following along, just make those two changes. We have our server, and we have our client. There it is. Now we select, there we go. And we're all working. Oh, look. Let's see who's going to win. Place your bets now. Ooh. There we go, client's the winner. So, thank you very much for following the tutorial. I apologize if it's long, but I hope that you really understood the process, you understand the small nuances that you need to keep in mind. The main takeaways here, of course, are how to synchronize the board state, and specifically in a simple application like this, we want, because JavaFX is not thread safe, we wanted to create a flag every time we press something, and then in our game tick method or loop, we process that. So just a reminder, here we go. When we handle an event when one of our toggle buttons is selected by updating this game state, and then in our run, which calls our game tick until the game is over, we update our board state on tile selection, which is here if it's my turn and game state updated. Otherwise, we process this turn, which doesn't need a game state updated flag because this input here will just read if it's there or not. So again, thank you very much for watching. I hope you were able to follow along, and you now know a bit more about networking in Java. Thank you very much.